Okay, good afternoon and welcome to the 2020 TI Term 2 student webinars. My name is Chris Harrison and I'm here to discuss with you further differential calculus in mathematical methods. So what we intend to do tonight, if we wish to discover the usefulness of user-defined functions and known as UDFs on a notes page, we're going to make and use widget. And we're going to use widgets in applications questions, differential calculus. Now to start off with, we're going to have a calculator page and we're going to use calculus to find the stationary points of the following. 2 cubics, and we're going to start by coming over to the calculator page, and the first thing we've got to do is define the functions. So f of x, we're going to use this sign key, x cubed minus 5x squared minus 8. Okay, now what we're going to do is use the derivative template, which is shift and minus. Variable is x, and when we get in here, I'm going to press the variable key and choose our f function, it's the only one that's there, and put an x in there. Okay, there's our derivative. What we can do is we could now solve that. So, menu, calculus, menu algebra, and solve. And I'm going to go up arrow. It's back to here because we could have typed this in right at the start, and comma. And we have to solve to find the stationary points where this will equal 0. So we get 2 values. Now we have to find the y values. So we're going to put in f of 0 and f on 3. So we have our 2 stationary points of 0 minus 8 and 10 on 3 minus 716 over 27. So we're going to look at our second function and we're going to define it. So g of x. Use the assign key again. And we'll type in our function. They're very similar functions, so I hope in the background you're thinking what the change will be when we do that. Okay. This time when we solve it, we're going to use a slightly different method. I'm going to go to algebra, and then we're going to go to 4 zeros, and then we're going to put in our template, so shift for the derivative and minus. We're going to put in an x, and this time when I press var, we see that we have 2 functions defined on this page, and we select G and we press enter. Now when we do these, we've got to make sure, as it says there, that we put in the variables. So don't forget the syntax, which you've got to do, and it's all good. Now to find, if we notice, just look at the output that the CAS gives us. We've got both values for the x values of the station points in a nice little way compared to what we had before. We had it separated with x equals 0 or x equals 10 on 3. So this is a much nicer format for setting it out. And it's even better when we come to work out the y values. I could just go up arrow in the history and press enter, and both values get pasted in, and this time both values appear. So we have minus 15 on 3 is the x value for the first one, 10 times root 15 on 9 minus 8 for the second one, and the other one is root 15 on 3, and just because I've got a small screen there, I've got to go across and it's minus 10 root 15 on 9 minus 8. So they're our stationary points. So you would be copying them down onto your answer sheet that you have. So this time we're going to do a very similar thing. This time we're going to work on our notes page. And hopefully you'll find a little bit about what a notes page can actually do. So the first thing on your activity sheet, I've put a few more instructions on that one, so I hope you're following on there with what I'm about to do. So we have to put in what's known as a math box. So Control M is the shortcut. This is an equation box. It's a formula box, which allows me to perform some things. So the first thing I'm going to do is evaluate and enter the first function. The assign key, and power 4. Make sure you go across arrow, and minus 5x squared and press enter. And it says that it's done. So if we now hit the var key, we see that f is already defined. And automatically, when we do get this happening and press enter inside the box, another math box comes up because it thinks we're going to write another formula. Okay, so now what we're going to do is we're going to look at working out the x values of the stationary points, and we're going to do it like we did before. So if you just forget, we could go back and just have, we're going to do the second method, is here. We're going to look at the zeros. So if you were in the history, what you could do is you could go up in the history and you could actually copy that. So Control C, remember all the Microsoft commands work on here, and then go back to where you were in your diagram, and there'd be only one thing we'd have to change in it. We paste it in. Okay, so, and if you have a look up the top, we've got problem 2.1, problem 3.1. So we've just gone back to problem 1. And the only thing we'd have to change would be this value here, the fx. There's our two values. And just like before, we have to substitute those values in. So we go f, bracket. And what we could do is we could go up arrow here and copy this part and paste it in. Okay. Now, just a little word about that. I've been using my keyboard because if I'm going to make these widgets, what I suggest that you do is you do it with software which is available on the TI Australia website to download for free at the moment. Now, so we've got our stationary points, and there are 3 of them. And if we have a look, they're in the right order that they go. So minus root 10 on 2, minus 25 on 4. The first one, 0, 0. The origin is the second one. We've got root 10 on 2, and minus 25 on 4 is the third one. So that answers our first part. Now, instead of going up, like we did before back in the first question, instead of typing in the second function, we notice that both of these are named the same, fx and fx. So what we could do to work out the functions on the second one is this is where the notes page is really good. We can just go up here and click inside the box and edit the formula. So if we edit the formula and go across, and as soon as I delete something, you notice that done's gone. So I now have to put a minus 6 in there. And if I just arrow across and put my plus 8. Now, if I click outside the box, nothing's updated. So we've got to make sure that when we're back inside the box that I actually press enter. It says done, and automatically you see that the values of the stationary points have been updated. So we've got minus root 3 and minus 1, 0, 8, and root 3 and minus 1. So that looks pretty good. And the great advantage is that I could preset this up beforehand and have a file which has all this in here, and then all I have to do is come up and edit this formula there. Let's move on. Now, this time we want to work out the axial intercepts of our equation. This is the equation we had before. All I've done is copy across beforehand what we just did, and I'm coming down to the math box here. And if we want to work out the y-intercept, we know that that occurs when our function f is 0, and press enter. And we have to work out the x-intercepts now. And so to work out the x-intercepts, just like you always would do, we could just go zeros again. So menu, calculations. Now you notice that previously it was in a different order. The calculations, when we go down to number 6, is exactly the same as when we're on the calculator page. It's just in a slightly different spot. So I'm going to go 3 algebra, and I'm going 4 zeros. And what I need to work out is the zeros of f(x), and don't forget the syntax. We had to put a comma x in there. We press enter, and there's all our x-intercepts. So very quickly, we just have a scroll through. This was our information from the previous part. We've now added in the information in the question. The y-intercept is 8, and the x-intercept is -2, minus √2, √2, and 2. It's like a very symmetrical sort of graph, we could say. Now, this one, we now have to sketch the graph of y equals fx, labeling the coordinates of all the stationary points and axial intercepts. Well, we've already calculated all these points on the previous page, so really all we need to do is sketch the graph and then transfer from page 4.1 to our piece of paper or our exam paper, or SAC, whatever it is, and copy the graph. So we're just going to put in the graph. So tab, and if we hit var, we see that there's our f graph. We could just put that in here. We don't need to retype the function. It's there. And there's our function. And we could go to the Windows settings up here, Windows Zoom, and the Windows settings to alter that, but that's no need to do that. So the only thing that we can't quite see is the stationary point in the middle. So if we just double click on this point there and change that to say 20, now see what the graph looks like. So we can go through using this picture, copy the picture down, but we don't need to go through and do analyze graph to find all the other points. We just go to page 4.1. There's all the data that we can copy across. Now, just before we get there, now wouldn't it be nice if we could do this? Because if we have a look here, it says sketch the graph of this graph, okay? And it says insert the created widget. Well, our widget is a compilation of all the things we've done over the next pages. So in the format it is here, I can't create a widget. So what I've done is taken all the information that we just did, and I've put it on a separate document. There's our graph page that we just did. The only difference is I put that 10 there. So let's make that 20 up the top. That looks exactly the same as what we had before on those 2 pages back there. Now, if you notice also, what I've done is I've put in some extra information. So in our notes page, we can just type in things, just text, whatever you like. So on your handout, it suggested that you should tidy up and format the page a little bit. So I've gone and put that in there for you at the moment. And you notice that I've got some red colors, so you just have to highlight some text, and we'll just get the whole line. If you prefer a different color, we could go through and format the text, or we could go to the color and just pick the color. So, and maybe you prefer a orangey color. Well, didn't see what it was called, but we've got a different color there. Okay. If you didn't like that color, we could always press undo, Control Escape. Now, after I highlighted it, when you're on your computer, I did a right mouse click, but if you want to right mouse click on the calculator, it is actually Control and Menu. And there's the format text or the color. So format text, I can make the text bold if I want, so let's make that bold so it stands out. Okay, and there it is. Now, the other thing you might like to do on this page is quite often you don't need to see the formulas. I think it's important in some parts that you actually keep the formula there. Okay, so we've got the formula there that we type in, and we've kept the done so we know that something's actually happened. But you can actually hide some of this information if you don't think it's relevant. So the zeros formula, we may want to keep that for reference, but we don't always have to. So if I'm actually in the math box, if I do a right mouse click, remember that was Control and Menu, I go to the math box attributes, and up in this top box, got a few options we could use. And I could, at the moment we're showing input and output, I could hide the input, or I could hide the output, or I could make no calculations, which we'll talk about a bit later. So if I hide the input and then press OK, oh, looks like nothing's happened. But as soon as I click outside the box, it's all up. So that might look a little bit neater. And we don't need the formula, we just need the answers. So just once more, I'll do it for this one here. So if you go inside the box, and if we went Control Menu, and there's our math box attributes. I don't want to see the input, so I click this box here, and I hide the input, and OK. So again, it doesn't take effect until I take it out. And you could do the same for the others, or you may like to leave it there. Now, the next thing we want to do is we want to save this. Now, we're going to save, and what's the topic was on the learning intensive was a widget. Now, if you notice, we've got two pages. On this page, we've got a notes application. On this page, we've got a graphs page application. What we need to do to turn this into a widget so we can use it again is we have to combine those two pages. So if we go Doc, Page Layout, number 2, so, first we're going to go Group. Okay, there they are, the 2 pages is there. Okay. Now, if you notice, there was a shortcut there, so let's just have a quick look about that again. So, Page Layout, and the Control 4 is the quick control to get there, and Ungroup, which we'll use shortly, would be to ungroup the pages to put them back how they were. So remember, Control 4, Group, Control 6, Ungroup. Let's just escape out of that. Okay. Now what we have to do is we have to save our document to the widgets folder. So let's go Doc. And I'm going to go File this time. Oh, cancel that. Now, when I use a mouse, sometimes this gets a little bit annoying, so press the keys, 5 Save As. And I need to go down and save it into my widgets folder. I'm going to select my widgets folder. Now what we have to do is we have to give it a particular name. So we pick a name, and we might call that graph. Yeah, oops, if I can spell it. And hit save. Okay, so that's saved. All right, so now we're going to use that very shortly. So we're going to go back to our other document, and we'll go to the next problem. And it says we want to insert a created widget. Okay, so if I now go Control and add a page, or I could go Control I, and I want to add a widget. Okay. There's several widgets here that we've got. There's our graph widget, so let's just select that and add it. And there it is. That's what we just did. Now you notice that we're in problem 5, here 5.1. Now on this page we have one page, it's 5.2, but we have two applications on that one page, a notes page on this side and a graphs page on that side. Okay, so I'm just going to go back, and we had to sketch this graph. Now this is going to be very interesting for what we've got. Okay, remember when we edited things on our information here, it updated things automatically. Now what don't you see? Now we did mention about Control 6 was ungrouped, because that's just too small to see, so Control 6. Okay, now the other thing you notice is all our formulas are turned off. So could go through and do them one by one manually, but that takes too long. So I'm going to use another Microsoft command, which is Control A. It selects all. And if we go to the menu and we go number 1, actions, and then number 1 again, evaluate. And what has it done? It's activated every formula in our math boxes that we had on that page. Okay, so now what we're going to do is we're going to edit in that formula. So we're going to go in this box here, and we're going to put in our equation, which is an interesting equation. And this is why this one was there. Now, when you do write your own widgets, I strongly suggest you test them with many different equations. Oh, sorry. I put a control there, so I brought up the information. So we want our sign, and we want a 2x in there. Now I'm just going to press enter at the moment. And what we get is all the general solutions that are there. Okay, so it's got all the general solutions, and it's giving him some answers. It's there. We had a specified domain, so I'm going to go back in here and control equals back arrow to get to the given symbol, press enter. And then one thing we could do, if you forget where the pi button is, even though it is a key, we could just type in -pi on the handheld. And then we need to put in a less than. We're going to put in an x. And we're then going to put in a less than or equal to. And we then have to put in pi. So let's go to the pi button this time. Okay, now we're going to press enter. Now, we did notice here that it gave us the general solution. So what I'm going to do back here is I'm going to put a decimal point after the 1. Okay. Now there's some interesting things that come up here. Now, trig is very difficult. We wrote a very simple widget, and we find the x values are calculated there as 1, 2, 3 x values of station. But we find that with the formula we used, it creates an issue. Zeros command. So this is why I said you should test them. But we've got ways around that. So what we could do is we could put in another maths box, Control M, and we could now go through and evaluate these. So hit var to see what variables are in there. And just talking about variables there, you've got to be really careful about, and you notice it's changed all my colors, which it'll do occasionally. And I need to put in one of these values. So I could go and copy one of these values, or I could type them in. So I could go up and go Control C, and then come back down again and put it in there. And go Control V. So that's a short fix. Now I'm just aware at the time, so I'm just going to go to our answers and show you what I did to solve this. So what I did when I realized that it didn't work, I went and I copied all these points in there, and I also looked at the endpoints and substituted them for the graph. So let's have a quick look at the graph that's there. Here's our graph. Now, here we go, there's our graph. So what we'd do is we'd copy down our graph after first examining all these values that we've got. We have for our values of our x values, and we look at the y values of all those. and then we'd transfer that across to our paper as we're going to the graph here. We could zoom in again with our values as well. Now, one thing that you notice, to get the pi minus pi to come out, what I did up here was I actually changed this value to less than or equal to, because it's actually undefined at an endpoint. So there's a nice little trick. If you're on the notes page, we could change this to a less than or equal to, and it will bring up the answer for the endpoint. Okay, now I just want to show you a couple of things that we've got. Yep. I'll just go back to our questions page. So it says we've got to insert a widget, solve this one. So the product rule, here we go for our product rule. There you go. And we've got to show that. Now, show that question means that we need to show the steps in between. Now, can we actually do this with a widget? So again, Control I I'm going to do this time. And I want to do a widget. Now, if we go back to the widgets, I've got one there called number 2, which is a product rule widget. And again, Control A to select all the widgets on that page. Then we're going to go Menu, and we want to go number 1 Actions and number 1 Evaluate. Okay. Now all we have to do is go back and put an appropriate rule to place into the math boxes. So let's just have a quick look at it. So we've got to put in an x squared, and we've got to put in a square root of 2x minus 3. So on this page, we're going to put in the square root of 2x all right, 2x minus 3. Now, if we have a look, we've got our u and our v that we've defined. And then the bits after the dash line, you don't touch any of this. It's something I do on my widgets, meaning for my information, I don't touch that. And then it's automatically worked out the derivative of u, it's worked out the derivative of v. And then with a little bit of clever formatting, we've got how you would do it by hand. So it's a good practice with how you do it by hand. And then in the end, the CAS in this case actually went through and calculated it fully. Okay. So I'm going to have a look at one more of these. We won't do this one here, but you can do exactly the same thing. Actually, I'll come down here and show you since we've got a bit of time there, not a lot of time. So let's just have a look. So again, we're going to insert a widget, and I go through the same process as the product rule. And then I go and add them all in here, change it to the appropriate values. Now this time we had to find the derivative showing all the steps as if it was by hand. So we're using our CAS to show the steps by hand. So I've got the x squared and the e to the 2x in there. So I've put my x squared in here, and I've put my e to the 2x in there. As soon as I press enter, every formula was updated with those rules, and we can see that it's almost the same as what was required in our answer here, this part, and you can see some of the rules that are there, except we have to take the 2x out as a common factor. So not always will the CAS actually solve the things that you want to find. So you may have to do a little bit of work yourself. So again, we had to show that the derivative was this. I'm going to move along. Yeah. Got a one which is the chamber was an example as well. So you can have a good look at that. And remember, you will get access to all these files because you've attended. And I just want to talk about some strictly increasing, decreasing. So the function y equals fx is strictly increasing on the interval between a and b inclusive if for every element in that interval is f of b is greater than f of a. So the larger value y would be slightly bigger than the smaller value substituted in. And strictly decreasing is almost the same thing, except when we come down to here, f of b is actually less than f of a. And we're going to consider this function y equals minus x plus 2 all squared times x minus therefore we are to state the maximal domain over which the function y equals fx is strictly increasing. Now we've just got a little chart here that we could see what's going on. It's similar to if you tuned into our last webinar. So just take note, we've got the blue graph, which is the function we're looking at. We've got the red graph, which is the red line coming down here. I've put in the stationary points up here in blue that correspond with the blue graph. Strictly increasing, remember f of b was greater than f of a in the interval between a and b. And as we have a look, I've also got down the bottom here the derivative graph. And when we come down, it's connected to that. So if we come down here to the stationary point, we're at 0. Obviously, a value which of y is larger in the red section there than at this stationary point. And therefore, we're going to continue up, and the graph is steadily increasing. Watch the gradient as it goes up. And we keep going up to the stationary point here. There's the maximum. Okay, there's the maximum. So as we go up, we saw that as we increased, and remember the rule says between a and b, f of b must be greater than f of a. So when we're back here at stationary point there, I went a little bit up higher. It was bigger than the value of the stationary point. As I increase up here, it was always a little bit larger. The f of b was slightly bigger. When I come up to 0.22, we find that this point here is slightly larger than a point which is before it in the y values. Therefore, this function is strictly increasing between and including -2 to +2. And I just have one more question to look at, and it's going to involve a widget. So a particle moves in a straight line so that its position x meters from a fixed origin O at a time t seconds is given by x of t equals t cubed minus 6t squared plus 9t, where t is greater than or equal to 0. We've got 3 questions we've got to do. How far is the particle from O after 4 seconds? And what is the velocity of the particle at any time t? And when is the acceleration of the particle? 5 seconds squared. 5 meters per second squared. So I'm going to come through here and just go up to our last question. Okay, it says I've got an inserter widget. So I have to go Control, Page, Inserter widget, which is number 8. And if I scroll down here, you'll see that the 5th one is something to do with kinematics. So again, all the formulas are turned off. So if you guys can remember, Control A, and then we have to go Menu, 1, okay. And now they're all turned off. So I'm just going to scroll up so we can see what's there. And we have to enter the rule up here. We're just going to put in the rule. We get back and have a look. It's t cubed minus 6t squared plus 9t. So t cubed. Go across and was minus. Okay. Now this time I'm going to leave the domain out because we all know that for time values it's going to be greater than or equal to 0. So I'll just leave that out. And nothing's updated yet. As soon as I press enter, it's done. And all the formulas are updated. Okay, so now the red box line says that don't touch those two because they're the only things that are going to be updated automatically. The first question, refreshing here, was how far is the particle from O after 4 seconds? So we're going to scroll down a little bit and we're going to go to one of these math boxes. So we're going to hit var. Now on here we have a few functions defined. Okay. So we wanted to know the x position one, and it was after 4 seconds. So if we put in a 4 and enter, we know that the particle is 4 meters from the origin, because that's the position equation. And it's 4 meters, because it's positive, it's 4 meters to the right. Second question says, what is the velocity of particle at any time t? Well, you know that's the derivative. We don't have to actually do anything here. We just have to write down this equation. So that's all good. That's the second one done. And for the third part, we had to find when the acceleration of the particle is 5 meters per second squared. So we go back down to our second one, the math box there, and hit menu and calculations. And we want to go algebra, and then we're going to go solve number 1. Now we want to know when the acceleration, so let's go A, and the variable is t. We want to know when that equals 5 meters per second squared. And again, I have to put in my syntax correctly so that it's got a solving for t. I press enter, and the time occurs at 17 on 6 seconds for that question. Now just recapping a little bit here. So we see that our math boxes and our widgets, we update them as we go through, and we just edit them appropriately by just going in the box. We can have some questions where we have the rules all set up beforehand. So if we're going into an exam question, we could have several of these set up beforehand. And we can also set it up where we can still use the notes page application to calculate other things with questions. So we can add to our page. But this Kinematics page has some basic things that are in there. And I'm going to say we are done.